All right, let's continue on with the arithmetic sequences and knowing what is called partial sum. So remember that famous mathematician Gauss, and you learned about Gauss in chapter 6 prior to this, but he found while he was in grade school, so elementary school, that when adding numbers according to a fixed pattern, there's a quicker way to find the sum of those numbers. Sometimes we need to find the whole total. And no one wants to go through and add up each number if you have 100 and something in a total. So he discovered two formulas to find what is called the nth partial sum. Now, the first one looks a lot like the general form of the arithmetic forms, for the sequence. The inside, this part right here, is exactly like the general form, except that there is a 2 in front of the a of 1, and then you divide or multiply it by n over 2. So this second piece right here, and you can see these two pieces were added to the arithmetic general form. So make sure that you don't get that one confused with finding a number in the sequence versus finding the partial sum. Now the other one is the sum of however many numbers equals n times the first number and the last number in the sequence divided by 2. In other words, this is the number associated with the final position. Now, we may not know the final, and other times we do know the final. Or we can find it at least easier than the other one. So it all depends on what type of question is given to which one would be easier to use. Do know you have to know these different formulas for the test. You're going to need to know them. That means you might want to get some flashcards out and get started with the formulas. So find the partial sum of the following sequences. Well, the first one is the sum of the first 40 numbers if given this amount. So we want the first 40, and we have these numbers in the sequence. I don't know what the final is. Because I don't know the final number, I'm going to go ahead and use formula 1. So I'm going to use formula number 1 above for the partial sum. I need to know a of 1, which is given. So a of 1 equals 3. I need to know what the d is. Well, let's go up and find it. It has to be consistent all the way through. So 3 to 7, that's a plus 4. Then check the rest of them given. Is 7 to 11 a plus 4? It is. Is 11 to 15 a plus 4? It is. If it is not consistent, then it is not a sequence. So our difference is 4, a positive 4. I don't need the plus on it. And I need to know n. Well, n is 40. I want to know all 40 terms. Okay, so let's just fill in the formula. The partial sum, or the sum of the numbers of 40 numbers, are going to be 40 divided by 2 times 2 times a is 3, plus 40 minus 1 times d, which is 4. Now, please use your order of operations correctly, PEMDAS. Well, I would reduce this, and this would be 20 times, I have multiply this piece and multiply this piece once this inside the parentheses is done, which is 39. So 39 times 4. The first one is 6 plus the 39 times 4, which is 156. Then add the two together and multiply by 20. I get 3,240. That is your answer. That is the sum of all 40 numbers without adding them. This is so much faster than trying to list all 40 out and then add them together. Of course, you can if you really want to, but it's not something I would prefer to do. So on this next one, find the sum of the first 50 odd numbers. Well, okay, let's think about it. Which one should I do? Eventually, I'm going to use formula 2. But if we use formula 2, I then need to know what a of 1 and a of n are. Well, I do know. What do we do know? I do know, therefore, that a of 1 is easy to find. What's the first odd number out there? It's going to be 1. I do also know the d, because odd numbers, it goes 1, 3, 5, so forth, are adding 2 to it. And I need to find a of 50. Okay, so let's write our specific general form. This is step 1 of what I would do using this form, is to write a specific general form. Well, that would be a of n equals a of 1 plus n minus 1 times 2. That's from our other side of our notes. Well, I do know what n is, so plug it in. I have a of 50, because remember we want the 50th, the a of 50. That's what we need to find. So a of 50 is going to equal 1 plus 50 minus 1 times 2. So a of 50 is going to equal 1 plus 49 times 2, order of operations, and I get 99. So now I know what my a of 50 is. So I'm going to push this up, guys, sorry. Okay, so step 2 is to find the sum. Find the partial sum. And they call it a partial sum because a sequence can continue on for indefinitely. And so a partial is saying, I want this many of that sequence. That's why it's called partial sum. I have S of 50 equals, again, n, that's our form up above. So 50 times a of 1, which is 1, plus a of 50, because that's the last one in our sequence, all divided by 2. Order of operations, I'm going to have 50 times 50, and I get 2,500. So the sum of this partial sequence is 2,500. I would not want to write all 50 numbers out and then try to add them. Most likely there could be a very easy math error to occur on that. So let's go to a word problem. Yes, final application. Here we go. And an amphitheater has 50 rows of seats with 30 seats in the first row, 32 in the second, and 34 in the third, and so on. So find the total number of seats. Total number of seats means the sum And let's write down what we know. We have 50 rows of seats with 30 in the first, 32 in the second, and 34 in the third, and continue. So we need to know how many are in row 1. Well, that's easy. So let me write that. We know seats in row 1, which means I know A of 1 equals 30. That much I know is first row. And let's write the sequence. Let's just write the sequence that we know. We know that row 1 is 30. Then it goes 32. Then it goes 34. And continuing on so forth. We can easily find what the D is. The D is going to be 2. It's the difference, and this is also a plus 2. So just from this information, I know my A of 1, and I know that D equals 2. If you look above at the two different types of sequences, or sums, excuse me, partial sum formulas, the one on the right, includes the last position. Well, I don't have that information. So I look at the one on the left and I go, do I have enough information that I can just solve with that? Do I know my N? That's the number of rows. So I know my N, I know my A of 1, and I know my D. So I would use Formula 1. S of 50, the 50 rows, is going to be N, which is 50, divided by 2 times A of 1, 30, plus N is 50 again, minus 1 times D, which is 2. Please memorize these formulas. It'll be very easy just to add the 2 and the N over 2 once you have the general form sequence from the 30 over. Memorize the A of 1 plus parentheses N minus 1 times D. Once you have that down, then you just add the 2 and the N over 2 for the sum. That one should be pretty easy if you can remember those two different things. Now, this is going to be the same as 25 times 60 plus 98, which equals 3,950 what? We're talking seats because this is application and needs to be titled. So there are in those 50 rows 3,950 seats. This is applicable a lot to the building of stadiums. So how many people can they cram into a stadium to make the most profit? So some stadiums have more leg room than others. If you've ever sat in a stadium for baseball, football, whatever, some are better than others because of what their decision was. Was it worth giving them more space to sit so those that are tall don't have their knees crammed into their chest? Or is it better just to fit as many people as they can and they'll have to deal with being uncomfortable because we'll make a bigger profit? So consider that next time you're at a stadium or theater or any of those.